Hey guys, so we'll be continuing with our IGCSE paper 4 for the year 2016 May-June spec. Anyway, so if you haven't seen the previous parts, we're basically at question 6 of the paper and we'll be completing the entire paper in this part, hopefully. I know it's been a long time since I uploaded one of these videos. It's been almost 2 months since I did it, and I've just been busy with a lot of stuff, including internal assessments for the IB and everything, so it's just haven't gotten time to continue on with this, but in this video I'll be completing this, and then hopefully I can get a bio paper in before my exams or after. I'm not really sure. So anyways, let's not waste more time. Let's continue with 6a part 1. So 6 says zinc is extracted from the ore from an ore called zinc blende, which consists mainly of zinc sulfide, ZnS, which is the formula. So the zinc sulfide in the ore is first converted into zinc oxide. Describe how zinc oxide is made into zinc sulfate. So let me see if I remember how to do this. So zinc oxide is made from zinc sulfide. This is again, that's your formula. You need this for the second part anyways, if you don't remember. So basically the process in which you convert this is basically you say, so roasting is a process in which you convert zinc oxide to zinc sulfate. So that's basically the process in the presence of oxygen, because you need an oxide, so where else are you going to get it from? Presence of oxygen. The process itself is called roasting, and the second part asks what's the chemical equation. So you do ZnS. I do not believe you need a state symbol, so you put O2 and you get ZnO just to balance it. So basically you put a 2 in front of the Zn, to balance it. And if I'm not wrong, that means you have to put oh, I forgot the SO2. You get SO2 because of course you have to get the sulfur. So to balance this again, you put a 3, this is the 3O2, and then you get 4, so you put a 2 in front of the SO2 as well. So you get zinc sulfide plus oxygen gives you zinc oxide plus sulfur dioxide. That's your equation. So the process is called, this is basically roasting. That's roasting. That's what it's called. You could say burn or heat, but roasting is the correct term basically in this. So anyways, the next question we do, zinc oxide is converted into zinc. Zinc oxide and coke is fed into a furnace. Hot air is blown into the bottom of the furnace. So anyways, coke is basically just carbon. This is carbon. Don't get this mixed up with the drink. I'm pretty sure they wouldn't use carbohydrates to form zinc, but it's carbon. That's all you need to pretty much know. Hot air is blown into the bottom of the furnace. Zinc has a melting point of 420 degrees and a boiling point of 907 degrees. The temperature inside the furnace is over 1000 degrees. So anyways, part 1 says explain how zinc oxide is converted into zinc. Your answer should include details of how the heat is produced and equations for all the reactions you describe. So basically, the first equation is, the first part, the carbon itself, the coke, reacts with the oxygen in the vessel to form carbon dioxide, and since that's combustion, you get exothermic reactions. So you basically get C plus O2 gives you CO2. That's your first equation. And then, this is basically exothermic. This is exothermic. and then you get some of this reacts with the excess carbon. You get some more coke which reacts with carbon dioxide, which is this, to form carbon monoxide. And this basically reduces the heat a bit more. 2CO. This is a bit endothermic, if I'm not wrong. And then this carbon monoxide, basically displaces the zinc from the zinc oxide to form the zinc metal plus carbon dioxide. So this is because zinc is lower in the reactivity series than carbon, so you get displacement. Yep. Yeah. So these are the three equations you need to do. Alternatively, you could say carbon burns in oxygen to form carbon dioxide, and then it does that, but I personally just remember these three equations, and I think that's the easiest way you could do it. These are the three steps. So let me repeat. You get carbon, coke, which first enters the furnace, reacts with the oxygen to form carbon dioxide. Since that's that's combustion, you get exothermic. It's an exothermic reaction, and heat is produced. And some of that coke reacts with some of that carbon dioxide, which is formed to form carbon monoxide, which is endothermic. And then this carbon monoxide is used to displace the zinc from basically this carbon monoxide displaces zinc from the zinc oxide to form carbon dioxide and zinc. So that's pretty much the equations. So I'll just erase this in order to make this a bit more clear for you guys, because I don't think it's clear at all. So that's your three equations. I just remember it that way. I don't think steps just get too messy, to be honest, like writing each equation out in words. It's just simpler, and this gives you marks anyways. So the next question says, explain why the zinc produced inside the furnace is a gas. Well, that's because the boiling point is 907, as it says in the question, and the temperature inside the furnace is over 1000 degrees. So basically you say temperature inside the furnace is greater than BP, which is the boiling point of zinc, 907 degrees Celsius. That's 1 mark. You just say that temperature inside the furnace is greater than the boiling point of zinc, basically. And so the next part says, state the name of the physical change for the conversion of gaseous zinc into molten zinc. So gaseous to molten, you have to see that. So basically this is just condensation. That's the name of the process. It's similar to like water vapor converting into liquid water. Vapor converting into water, yep, condensation. So that's pretty much 1 mark. You just say that and that's 1 mark. So anyways, I know I'm rushing through it, but I think it's easy because these questions are simple, one statement questions. So the next part is, rusting of steel can be prevented by coating the steel with a layer of zinc. Explain in terms of electron transfers why steel does not rust even if the layer of zinc is scratched, so that the steel is exposed to air and water. So in this case, it says electron transfer. But the first part you need to say is zinc is more reactive than iron, which makes up steel. That will get you 1 mark. Reactive than iron, and you can verify this by looking at the reactivity series, which in the IGCSE you have to memorize pretty much. At one point, this will get you 1 mark by stating this. Anyways, so in this case, you just say zinc loses. So because it's more reactive, it's more willing to get oxidized, which is just loss of electrons. Zinc is losing electrons because it's more reactive. So it basically preferably gets oxidized in preference to the iron. Anyways, then the next part is, so the electrons, these electrons basically move to the iron in the steel. Move to the steel. And the final point is, as a result of this, the iron does not lose its electrons because it has extra electrons. These ones preferably does not lose electrons. That's simple 4 points, basically. These are the 4 steps you need to remember. Just in this order. The first part is simple. It's more reactive. This means it loses electrons because it's more reactive. It gets oxidized. And then these electrons which are produced, they move to the steel. And because of this, iron itself does not lose its electrons. So the next part is, when a sample of steel is added to dilute hydrochloric acid, an aqueous solution of iron 2 chloride is formed. FeCO2 is formed. When a sample of rust is added to a dilute iron chloride, an aqueous solution of iron 3 chloride is formed. So rust is basically iron oxide. That's all you need to know. Fe2O3 is the formula for rust. It is just iron 3. It's iron 3 oxide if I'm not wrong. Yeah, it should be iron 3 oxide. Yep, so this is just quantitative data. This is something they generally ask in paper 6, but they can ask in paper 2. So basically, iron aqueous sodium hydroxide, iron chloride, iron 2 chloride. So in this case, you get FeOH2. This is iron 2 chloride. Iron 2 chloride and sodium hydroxide. See, which the color of it is basically green. And it's also insoluble in this solution. So you get a green precipitate as a result of that. It's just something you have to remember. Iron 2 chloride, it generally forms green compounds, and they generally precipitate out. That's a cation test. And in iron 3 chloride, you basically get FeOH3. And this is brown, basically. It's a brown precipitate because it's insoluble again, and that's the Fe3 plus ion test. So from this you can see that, from this you can just say Fe3 plus always forms brown, Fe2 plus always forms green. That's the cation test, and the precipitate bar is always going to be there. This is qualitative analysis of chemistry, and it's always asked in paper 6. the alternative to practical, they generally ask you questions like this. Iron salts are put in. So you need to remember that iron 2 always forms green, iron 3 forms brown precipitate, iron 2 is green precipitate. So that's pretty much it for 2 marks. Anyway, solutions of iron 2 chloride and iron 3 chloride were added to solutions of potassium iodide, acidified potassium manganate, potassium 7 manganate. So from this, basically you can already know that potassium manganate, which is also potassium permanganate, or KMnO4 is the formula, or this is Ki, this is just a salt. So basically this is an oxidizing agent. While this is reducing agent. So this, you can see the table, potassium iodide has no change, and acidified potassium manganate of 7 that has a solution, it changes from purple to colorless. So solution turns from colorless to brown, no change, iron 3 chloride. So anyways, what types of substance cause potassium iodide solution to turn from colorless to brown? So potassium iodide is a reducing agent. So it reduces it basically gets oxidized itself because it's reducing something, so it's getting oxidized. That means it basically gets reduced by an oxidizing agent. The colorless to brown part is just it getting oxidized, potassium iodide itself, because it turns, I believe it forms iodine that as a result, and then it gets reduced. So basically, to get reduced, you need an oxidizing. For it to get reduced, the thing itself. No, I'm sorry, it gets oxidized. That's a mistake. I realized that. Hang on, let me just clear that. It's kind of, I get confused between the two as well. But it should be oxidized, since oxidized. So anyways, so it's kind of tough to explain, but it's oxidized because this thing is a reducing agent and something oxidizes it. There's something which oxidizes potassium iodide is basically an oxidizing agent. And you can learn this by the tests as well if you do on Google. They basically have a page and then it describes how potassium iodide is a test for oxidizing agents or something like that. So anyways, potassium manganate to turn from purple to colorless. This is basically a vice versa situation. So in this case, potassium manganate gets reduced, so it's a reducing agent. It's just the exact opposite of what you saw. So anyways, I'm not sure how to explain the second part. It's literally the opposite of that, I guess. You can just learn that potassium manganate gets reduced in this situation, so it's a reducing agent. And then it's the opposite in the top one. So which ion, basically you can remember, if it's potassium manganate, the solution, it's probably, if it turns from purple to colorless, it's getting reduced. If it turns from colorless to purple, it's getting oxidized. If it's turning brown to colorless, it's reduced. It's getting reduced. If it turns colorless to brown, it's basically getting oxidized. So which ion in iron 3 chloride solution causes potassium iodide solution to form? Which causes potassium iodide to turn from colorless to brown? So in the iron 3 chloride solution, it's basically the Fe3 plus ion, which causes it to turn colorless to brown, because this is what turns into because this is what literally gets reduced. It turns into Fe2 plus, and then as a result it gets reduced, so it's actually Fe3 plus which causes this to turn brown, basically. The fact that it turns into Fe2 plus is the reason why. So the answer is basically Fe3 plus. Yeah. It's just a 1 mark question. You have to, I guess my explanation was not that great, but it's just Fe3 plus because that's the only ion that basically affects iodine in that case. And the bottom one, the iron 2 chloride, it's just Fe2 plus again, because again chloride plays no role in this. And because it causes it, and then as a result it's just the opposite happens. So it's just Fe2 plus as it goes to Fe3 plus, which I shouldn't write because it gets people confused as well. So it's just the Fe2 plus ion because it has no effect on, the chloride has really no effect in this situation. So anyways, with that we come to the end of the question paper. Anyways, if you have any doubts, just let me know. I can remake another part explaining some questions again, and I will see you later.